Greetings, everyone, and welcome to the Pan Future Society podcast. Today is Saturday, June 10th, 2017, and thank you for joining me. I got no rant to roll with at the top of the show, so let's get right to the news of the moment. Researchers at Purdue University have developed a new design for a battery. This battery could prove to be a very large breakthrough, especially in the world of electric vehicles. The battery is instantly rechargeable. It means you don't have to sit around and wait, and it is also affordable, environmentally friendly, and safe. What they've done is design a new model for a flow battery, which does not require an electric charging station. Instead, you just replace the battery's fluid that contains the electrolytes that run through the battery. So instead of charging the spent part of the battery when it's dead, you just replace it. And you do so at some sort of filling station, much like you do now, and you deposit the depleted electrolyte fluid and get some new stuff. And it's pretty much as quick as it is now to fill up your car with gas. This battery design is also unique in that it does not have the membranes, which are expensive and prone to failure in normal battery design. One of the researchers quoted here saying, "Membrane fouling can limit the number of recharge cycles and is a known contributor to many battery fires. IF batteries components are safe enough to be stored in a family home, are stable enough to meet major production and distribution requirements, and are cost effective." So, this is kind of something that dovetails into the main show today. Battery energy storage technology. That is one of the most important leaps in technology that we need to make some big steps forward. So, look for this thing. And they founded a company called IF Battery to commercialize and develop this technology further. So keep an eye out. By the time electric cars are very, very common on the roads, we might also have electrolyte filling stations for them. The second news item I'm going to bring you this week, I have a couple of articles I'm going to post links to you can check out. And it's all about artificial intelligence. There are some new pushes to get a better look inside the black box of artificial intelligence. When an AI runs through its algorithms, we're not really entirely sure how it gets to its conclusions. We have some vague ideas. We sort of set up some parameters for it. But when an AI decides that a picture is a picture of a cat, we're not really sure how exactly every step-by-step thing is happening in there. So one group of researchers has developed a program that they can run to run backwards through the neural net's decision process. And they get a better look at how it's come to those conclusions. And if we know how, they can refine the development of those programs of the AIs to help them make even better decisions. Another group at Oregon State University has received a grant from DARPA to do much the same thing. But in this case, instead of sort of trying to run the decision process backwards, they are researching ways to get the AI to explain itself, essentially. Ultimately, we want these explanations to be very natural, translating these deep network decisions into sentences and visualizations, said Alan Fern, principal investigator for the grant and associate director of College of Engineering's recently established Collaborative Robotics and Intelligent Systems Institute. So, there could be in the near future, if an AI concludes that, this patient has, 95% chance of having this disease, the AI that came to that conclusion will be able to clearly and simply explain how it came to that conclusion. One kind of fun thing for us gamer geeks here, to start the development of the system, the researchers are using real-time strategy games like StarCraft to train artificial intelligence players that will explain their decisions to humans. So there you go. Video games are going to be used to program the robots that will run our lives in the future. But, when the robot uprising happens and our robot overlords take over, at least they'll be able to clearly explain why they did it. I'm kidding. I'm just kidding. Overlords don't need to explain anything. And that's your news of the moment. So. This week on the main segment, we wade into the topic of power, the energy that we use to run our world. It's something that is all around us almost all the time, yet we give it very little thought. From burning wood and coal, to oil and gas, solar, wind, water, and yes, even nuclear power. Energy is an essential driver of technology and our ability to shape the world and the civilization we live in. Do we have enough? Will we have enough in the future? What ways of making energy are better? It's a complicated topic, and I think some of my conclusions might surprise you. And will there be a breakthrough in the near or far future that allows us to take a leap forward in our progress, here on Earth and in space? To begin, let's take a look at a snapshot of our energy use. Numbers vary widely by country or location, but it is true to say right now we still use fossil fuel for the majority of our energy production. Globally, in 2015, our energy consumption was 33% petroleum, 30% coal, 24% natural gas, all three of those fossil fuels, and then 4% nuclear, 7% hydroelectric, and 2% other renewables. So you can see by those numbers, globally, we're still at about 85%, 88% fossil fuel for total consumption. In the realm of electric generation itself, we're at 40% coal, 21% natural gas, 16% hydroelectric, 10% nuclear, 4% oil, and about 6% others, mostly renewable sources. So a slightly different picture in the electric itself. So the difference in those numbers being that electric generation and transportation are the two biggest uses of energy. So the difference in our numbers there coming from what we use to make electricity versus what we use to put gas in our cars. Use of fossil fuels made sense for a long time. Consumption wasn't as high as it is now. And in terms of the amount of energy you get, it's a high percentage. 1 gallon of gas was a good way to do a lot of work. If you want to get further into this idea, I will link to some information on energy conversion efficiency and energy cost by source. In general, though, solar and wind energy generation have, in the past few years, dropped in price dramatically and are competitive with fossil fuels. However, also I want to say in terms of the development of our modern civilization, I will not condemn people of the past for using gas and oil and coal. It was easy to get to, it was available, and we'd really still be in the Stone Age without it. So I will not condemn the people who didn't know that it was a long-term problem. However, I will condemn people who do know better now and still don't care. Anyway, moving on. Another part of the picture I want to set up for this discussion is our individual uses. Obviously, this also varies widely by location, by the country you're in. But I will give you numbers for the United States. Generally, the U.S. Is sort of, if not an average, we are definitely one of the highest users of energy in the world and one of the highest polluters. So you know what, if we're getting things together and getting better, then that's good for everybody. Anyway, some numbers here provided by the U.S. Energy Information Administration. In 2016, in our homes, we used 18% of our energy for cooling, 9% for water heating, 9% for lighting, 7% for refrigeration, 7% for heating our homes, 6% for televisions and related things like DVD players and game systems, 4% for clothes dryers, 2% for furnace fans and boiler circulation, 2% for computers and related equipment, 2% for cooking, 2% for dishwashers, 2% for freezers, 1% for clothes washers, and 29% for other uses. I think they need to break out those other uses a little better, but that other uses includes small electronic devices, including all your phones and tablets and whatnot, exterior lighting, pool and spa heaters, backup generators, and other things. What is not included in this list is electric vehicle charging. So by whatever means they collect all this data, there is your picture of how it's on average being used in your home. The vast majority of it for cooling and for other non-computer desktop and non-television electrical devices, more or less. And this picture for me brings to mind a thought I've had from time to time. When someone says, we should do something about this, and this is too much, or that's not enough, you need a whole picture. Because for years, even when I was a little kid, turn off the lights when you leave the room, don't leave the lights. By 2016, we've changed a lot about lighting. And lighting is 9% of our electric consumption. So are we focused, if we still focus on lighting to make things more efficient, are we focusing in the right place? So, whenever somebody points at a certain thing as an example, make sure you take it in context of the bigger picture. Regardless of when we stop using fossil fuels, eventually we will have to. We will run out at some point. Where that point is doesn't have a concrete date, but I found some trustworthy estimates. Oil and coal have been the largest resources for energy production, and peak oil and peak coal are two parts of this question. They generally have two definitions: discovery and production. The former is the point after which less and less of it will be available, and the latter is the point after which demand will fall, eventually making coal and oil economically non-viable. Where this point is on a timeline also varies by country or location. However, I think we are actually just beginning to see the second part, the production demand for oil and coal generation of electricity and fuel is just beginning to fall as solar and wind become cheaper. One generally widely accepted and sort of in the ballpark number I found for peak oil on the production side of it was in 2050, and many experts expect that by 2050, production will decline after that. I think we are seeing this clearly playing out with other forms of energy becoming cheaper, and with places, even oil producing countries in the Middle East are looking ahead and building massive solar farms and doing things like that to prepare for a time when oil is no longer needed. Whether or not this is because we can't find any more, or if it's because we just don't want to use it anymore, is slightly variable. And the other thing that is, of course, not known is what will happen to the world economy when peak oil gets to us and we really start to decline. We will have very different results if we are prepared for it and we hit peak oil because we don't need the oil anymore, or if we are unprepared and we hit peak oil and collapse into a mess because we don't have any other way to make energy. Peak coal is a little harder to pin down. It seems to be more widely variable in its number based on location, because some places use a lot more and some places have a lot more coal than others. But at least in the United States, some models have predicted 2150 and others as early as 2032. However, other more recent predictions have placed that on the earlier side of things, between 2009 and 2023 being a peak for the production side of coal in the United States. I will link to some information in the show notes here. I've given you just the very briefest thumbnail view of this idea, and mostly I do it because I want you to be aware of the idea of peak oil and peak coal. Not only that eventually we will run out one way or another, or we will stop using these fossil fuels one way or another. It's unavoidable. But also to consider that by many estimates, possibly within your lifetime, you will see this happening. This is not generally something that's 300 years down the road. This is much closer than you think. So as long as level heads and smart people prevail, I think we'll be fine, because we are already moving toward solar and wind and better renewables. And there could be some breakthroughs. I know I did a story a few weeks ago. One of the news blurbs was about a zero-emission power plant that used, I think it was natural gas on that. So maybe coal with zero emissions is possible. But also to some degree, I think we have to decide at some point to leave it in the ground. It can be very environmentally harmful just to get this stuff out of the ground, and we'd be better off if we didn't. As with many topics I've covered, the solution will be many-faceted. There is not one answer. It's complicated. The wind doesn't always blow, the sun doesn't always shine. Energy storage technology will be important. Is buying an electric car good for the environment? Maybe not if your local utility runs a coal-fired power plant. And nuclear energy is a good option. Yes, I said it. In a future show in this series, I will go into the why and how nuclear energy can be a good option for future energy production. But briefly, there are several modern and cutting-edge designs for reactors that are totally different from what most people think of with nuclear energy. Accidents like 3 Mile Island and Chernobyl happened at plants using 1950s and 60s era technology. Much more advanced systems exist now, and if your assumption is that nuclear is just too dangerous Take a moment to consider how many people have died from nuclear accidents versus those who have died due to lung cancer, asthma, and other ailments caused by fossil fuel air pollution. And farther into the future, will we ever get to practical fusion reactors? So far, stars are the only reliable place for that, but there is research that is making progress. Cold fusion has been fiction so far, but there are small hot fusion reactors working, particularly the W7X in Germany. And are there other hypothetical power sources we could harness for travels into deep space? I will be tracking those down in upcoming shows. There is your primer on energy production and power usage. A little picture of how we use it, how we make it, and little hints at what we might be doing more of in the near future. So the next few episodes are going to be all about energy, new and better ways to produce it, and possibly some fictional sounding things that might not be so fictional that we could use in the far future. Okay, there is your show for the week. Thank you, as always, for joining me here on Saturday morning. It's my Saturday morning. I have no idea what day it is when you're listening to the show. But if you want to tell me, you can come to the website, panfuture.org, and you can send me an email from there. Or you can find links to the Twitter and the Facebook pages and send me messages there. As always, if you want to help out the show, there is a donate link on the website, or always what also helps greatly is to have some reviews, especially on iTunes. If you get your show through iTunes or Stitcher or one of the other pod feed sources, please do write some reviews, and that is always a huge help to boost attention to the show. And that's all I've got for this week, assuming the power source at my house holds up. I will talk to you again in the future.